So let's do the one that I wrote down as the example. 3x minus 2y is 0, and x minus 2y equals 4. Okay. So example. All right, so solve the following. A. 3x minus 2y, whoops, equals 0, and x minus 2y equals 4. Okay, so this system we're going to solve by graphing. Let's actually add that in our instructions. Okay, so solve this by graphing. In order to do that, what I would want to do is put both of these into mx plus b form, because for me that's the easiest way to graph. So you would start the intercept, move by slope. If you want to use just intercepts, that's okay. I've talked a lot in class about this. We don't know where these guys are going to intersect, so we really need to fill out the entire grid. Now, I've put on Blackboard in this section the grid printouts so you guys can have those to graph with. I don't actually have graph paper, but I think I can. Aha, I can. Oh, that's good. I can make this graph paper, so that's going to be my paper. Okay, so first, I'm going to rewrite both. I'm going to rewrite both of those to be y equals mx plus b. And when I do that, so the first equation, I have, see, I'm going to subtract 3x, and then I divide by negative 2. So I have positive 3 over 2x, and 0 divided by 2 is still 0. So I just get y as 3/2 x. For the other one, I need to subtract x and divide by negative 2 again. So this one is going to be 1/2 x. So subtract x gives me minus x, divide by negative 2 gives me positive 1 over 2. 4 divided by negative 2 is negative 2. All right, so this is really the system that I'm going to be graphing. So I'm going to label these 1 and 2. So for my graph, I'm not quite sure where these intersect on the paper that I gave you guys. I think it goes up to 8 in each direction. So I'm going to try to do something similar. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, that's good. Okay. All right, so I got a little more than 8 in each direction. But generally speaking, I don't give you solutions that aren't on the grid. So this should be enough. All right, so for the first one, I'm actually going to plot each of them in their own color. So the first one is going to be the blue, and the second one is going to be the red. All right, so let's graph our first line. Y equals 3 halves x. So this doesn't have a b value, which means it has a y-intercept of 0, 0, because b equals 0. So the first one, we're going to start at 0, 0. And then we're going to move. So I've got a slope of 3 over 2. So that's positive. So I need either 2 positive movements or 2 negative movements. So I'm going to move up 3 and right 2. All right. So start at 0, 0. Move up 1, 2, 3, right 2. Up 1, 2, 3, right 2. Up 1, 2, 3, right 2. Whoops. Okay. And you should also move what I always call the backwards direction, so down and left. So down 3, left 2, down 3, left 2, oops. Down 3, left 2. So I get this. This is my line. And this is the line y equals 3 halves x, which I'm not going to worry about writing. Usually I would write that, but for this it's not really a big deal. Okay, for the red one, I'm going to, let's see, this has a b value of -2, so we start at 0, -2, and we're going to move, see, this is a positive 1/2 slope, so we can move up 1, right 2. So start at 0, -2, move up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2, up 1, right 2. Oops. Okay. And then, backwards direction. So down 1, left 2. The thing that's nice about doing this technique is I'm drawing on top of a blue dot I already made, so I know that that point is going to be my intersection because both of them got colored, or it got colored by both lines. And I'm going to go ahead and fill it out though all the way. So down 1, left 2, down 1, left 2, down 1, left 2. Okay, that's pretty good. So my solution then is this point right here where they've intersected, which is the point -2, comma, -3. Now, you guys obviously have calculators, so it's trivial for you to quickly plug this in to your calculator for both equations and make sure that it actually solves both of them.